This lesson is on the periodic table and how to use it to predict the properties of different elements in the periodic table. The first thing that we need to know is how scientists and how you will refer to the different rows in a periodic table. We actually call these rows periods, and you should grab some colored pencils and on the picture in your notebook actually color code these. Okay, each row all the way across is considered a period. You also are going to want to number these. I don't have them numbered on here, but you can do it on your own. And I would suggest numbering it in your notes on the picture that matches with this, and also turning to the periodic table in the back of your notebook and numbering the periods on there so that you can remember them. Now they just go in order. So this first period, period 1, is in red. So I would put a little number 1 right over here to the left. And period number 2 is in orange. Put a number 2 right over here. And period 3 is the yellow one all the way across. Put a number 3 there. And of course green is 4, light blue is 5, dark blue is 6, and pink is 7. Now, all of the elements in each row are said to be in that period. So all of the elements in this orange row are in period 2. So that would be including lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. That's this whole row. Those are all period 2 elements. Okay, if you need to pause to get your coloring and your labeling done, go ahead and do that. And then continue on when you're ready. So looking at your chart, which of these 3 lists elements that are in the same period? Would it be lithium, potassium, rubidium, and cesium? No, those ones are in the same vertical column, which is not a period. We have sodium, aluminum, and lead and bromine. Those are kind of all over the place, definitely not in the same row. But if you find rubidium and technetium and silver and tin, those ones are all in the same period. So your correct answer would be C. And which period are they in? Should be period 5. We also refer to the vertical columns in a periodic table. And again, on your notes, you should color code these and then go back to your periodic table in the back and label your groups. We call the vertical columns a group. Some people call them families, but most of the time we will call them a group. And as you notice here, red is going to be group 1. So all of the elements that are found in this vertical column, okay, are group 1. All right, put a number 1 right above the red. Group 2 is orange. You can put a 2 just above those. Now notice these ones that are in this low area, we skip them. They don't like to always follow all of our rules, so we're going to skip them when we're counting groups. That means group 3 is way over here. Yellow is group 3. Group 4 is green. And then this teal color is 5, light blue is 6, dark blue is 7, and pink is 8. So 8 groups, 7 periods. Again, you can pause the video here and finish your color coding and labeling if you'd like, and then continue when you're ready. There are some trends that we have in the periodic table as well. So this is kind of a breakdown. Here's your too tall. This is the short transition metals, and then we get your non-metals over here. The biggest atom that we're going to see in the periodic table is going to be way down on the bottom left. The biggest one that exists is francium. As you go up, you have less rings. That's why they get smaller. And as you go to the right, the atoms also get smaller due to the fact that there's more protons in the middle. Okay, so that's one trend that we see in the properties of the atoms on the periodic table throughout these groups and families. Some other trends that you need to understand. So atomic radius, that's how big the atom is. Okay, we know that as you go to the left they get bigger, and as you go down they get bigger. Okay, metallic properties. We learned about metals and nonmetals last trimester. If you go from this corner up here, as you move across, metallic properties will increase, meaning they'll have more metallic properties. Also, as you go down in the periodic table, these elements will gain metallic properties. And then the one that goes in the opposite direction is atomic number and atomic mass. As you go from left to right, they will increase. And as you go top to bottom, they will also increase. Okay, you're going to be responsible for knowing these on your test and applying them to different situations. So because we know these trends exist and that trends in density, boiling point, and other properties also exist, we can use this to our advantage to try to get around an idea of what a property would be. So I'm going to walk you through this example. Example says the boiling point of silicon is 3,267 degrees Celsius and the boiling point of tin is 2,603 degrees Celsius. What would you estimate the boiling point of germanium to be? Okay, the first thing you're going to want to do is locate these elements on your periodic table. And I find them in group 4. Okay, so I have just cut out a picture of just these 3. We have silicon here, germanium, and SN is tin. Okay, if you want to find those on your periodic table, that might be helpful. Now we know that there's trends for these things, so they're either going to be increasing or decreasing, but it will be periodic. There will be a trend. So we go, okay, I'm going to think the best way to do this would be to label it. So silicon had a boiling point of 3,267. We also know from the problem that tin has a boiling point of 2,603. Now that means since germanium is between these two on the periodic table, its boiling point will also be between these two, somewhere in there. All right. Now the best we can do is estimate. The best estimate I would make would be something that's about halfway between them, and it's about 600 degrees from tin to silicon. So I'm going to go up about half of that, 3,000 degrees, and say I would estimate germanium to be about 2,900. That's about the halfway point between silicon and tin. Okay, as long as you gave me a number that was somewhere between these two, it would be correct. Another property that we can predict is how atoms will bond. And we know that atoms from the same groups will bond the same way. They'll have the same ratio of atoms. So what I mean by this, okay, we're going to say we know that when carbon and oxygen bond, they form this compound CO2, where you have 1 carbon and 2 oxygens. Okay, there it is. If we look and we go, okay, what group is carbon in? Find it on your periodic table. Take a second. Pause the video if you need to. Carbon is in group 4. Let's do the same thing for oxygen. Find oxygen and find the group number. You'll see that oxygen is in group 6. Okay? So now we're going to try to predict how carbon and sulfur would bond, which is a totally different elements than carbon and oxygen, right? So we have carbon and we have sulfur. C for carbon, S for sulfur. First thing we're going to do is figure out what groups they're in. So carbon, we already know, is in group 4. Let's find sulfur. Sulfur is in group 6, just like oxygen. Now, since our original compound that we know is group 4 and a group 6 element, and it was 1 and 2, 1 carbon, 2 oxygen. Since this is also a group 4 and a group 6 element, we know that they will bond with the same ratio. So we should have 1 and we should have 2. All right? As long as the group numbers match, you'll have the same ratio, 1 and 2, 1 and 2, because group 4 element you'll have 1 of, group 6 element you'll have 2 of. Okay, let's try some more of these. These can be a little tricky. All right, a lot of times on your tests and your quizzes, you're going to see a problem like this. I'm going to give you a whole bunch of formulas that we know exist, and I'm going to say, how would these ones bond based on what we know up here? The best way to work through these is to first start out with your known compounds, and I would label what each group each of these elements is from. So look on your periodic table, find Na. And the group number for Na would be group 1. I'm just going to write it real small just above Na. I for iodine is found in group 7. Mg, magnesium, is in group 2. Chlorine is also in group 7. And I'm just going to go across this whole row of known compounds and write the group number of each element. So I have that to compare with later. Calcium is in group 2. Oxygen group 6. Aluminum is in group 3. Oxygen is in group 6. Carbon is in group 4. And chlorine is in group 7. Now, you come down, we know what the groups are for each of these different compounds. We're going to come down here and we're going to say, okay, how do we think that carbon and fluorine will bond? Well, first thing I'm going to want to do is figure out which groups those two are from. So the carbon here is from group 4. Fluorine is from group 7. Okay, so then we pause and we go, is there any element up here, or any compound that has a group 4 and a group 7 in it? And you go, look, this one does here. Carbon, group 4, chlorine, group 7. So these two match. Now we know that the ratio will hold true. Since this one that we know had 1 and 4, this one will also have 1 and 4. So 1 carbon, 4 fluorine. Notice the ratios match here, 1 and 4, 1 and 4. We can do the same thing for aluminum and sulfur. So aluminum is from group 3, sulfur is from group 6. We look up here, which one does it match with this time? You should have said this one here, aluminum oxide. Now for the ratios here, it's 2 and 3. So again, it will match up here. You'll have 2 aluminum and 3 sulfur. You can see that those match, 2 and 3, 2 and 3. One more together. Here we're going to do this one, potassium. K is from group 1, chlorine is from group 7. We go up here to find the known one that it matches with, and that would be here, NaI. Since this is 1 and 1, this one will be 1 and 1. And we get KCl, 1K, 1Cl. Try the other two on your own, and if you have questions, make sure that you ask.